T. Thornton and Andrew Rex. Okay, Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, the radius of a hydrogen nucleus is believed to be about 1.2 into 10 to power minus 15 meter. Okay, this 10 to power minus 15 is also called femto. Okay, so it does not make any difference whether we say 1.2 femtometer or 1.2 into 10 to power minus 15 meter. Okay, the radius of a hydrogen nucleus is believed to be about 1.2 femtometer. Part A. If an electron rotates around the nucleus at that radius, what would be its speed according to the planetary model? Okay, we have to determine speed. Part B, what would be the total mechanical energy? Okay, that is total mechanical energy meaning kinetic energy plus potential energy. Now we move to its solution. In solution, there is a table included as a snapshot. Okay, from this table we will take that value which we will need. Okay, because this table consists of a large number of physical constants. Okay, we will pick that value which is required from this table for the solution of our problem. Okay, now we are going to our solution in a formal manner, regular manner. Okay, we start our solution from the assumption that from the technique that equating the electrostatic force of attraction between electron and proton in the hydrogen atom to centripetal force we have. Okay, dear students, we know that in hydrogen, electron revolving around the nucleus and proton inside the nucleus has an electrostatic force of attraction. This force of attraction is governed by Coulomb's law. Okay, moreover, because electron remains revolving around the nucleus, so there is a force is needed to keep that electron within the orbit. Okay, that force is called centripetal force. Okay, so what technique we are going to adopt here? We are going to adopt here that we will put these two forces equal. That is to say, the electrostatic force of attraction between electron and proton as per Coulomb's law and centripetal force of electron. Okay, we have, okay, equating the electrostatic force of attraction between electron and proton in the hydrogen atom to centripetal force, we have F centripetal is equal to F electrostatic. Okay, this implies that in place of Fc we will use MAC. Okay, because according to Newton's second law of motion, F is equal to MA, Newton's second law of motion. Okay, here because force is centripetal, so with A, C will be written as a subscript. Okay, in the same way as C is written as a subscript of capital F to denote centripetal force, similarly small e is written as a subscript of capital F to denote electrostatic force. Similarly, C is written as a subscript of A to denote centripetal acceleration. Moreover, electrostatic force F is equal to 1 over 4 pi epsilon naught into E square over R square. Okay, dear students, this is governed by Coulomb's law. Okay, sometimes we use Q1 Q2 in place of E square. Okay, and 1 over 4 pi epsilon naught, this is a constant of proportionality. Okay, actually the Coulomb's law says that Fe is directly proportional to Q1 Q2 over R square. Here Q1 is a electronic charge, elementary charge E, and Q2 is also E. That so in place of Q1, Q2 we have used E square. So electrostatic force is directly proportional to product of charges and inversely proportional to the square of the distance between them, while this portion, that is 1 over 4 pi epsilon naught, is a constant. Okay. Um, so in place of Fc we have used MAC, while in place of Fe we have used 1 over 4 pi epsilon naught E square over R square. This implies that we have rearranged, we have used the value of centripetal acceleration. Okay, dear students, we know from our lower classes physics, general physics books, that centripetal acceleration is equal to v square over r. Okay, so in place of centripetal acceleration AC, we have used v square over r. However, on right hand side, no change, E square over 4 pi epsilon naught R square. Okay, what we have we have just used the value of centripetal acceleration. Centripetal acceleration is equal to v square over r. From here, if we keep v square on one side, then n will be divided on other side, that is to say m will be shifted to denominator while r will be shifted to numerator, and 1 r will be cancelled from r square, so 1 r will remain in the denominator. Okay, that is to say v square will become equal to E square over 4 pi epsilon naught r into m. This is equation number 1. Okay, this is simply v square. Okay, from here we will find the value of v. Moreover, if we multiply it with if we shift m on right hand side in the denominator to other side of the equality, then this m will be multiplied with v square. Okay, moreover, if we multiply both sides by 1 by 2, then half mv square, which is equal to kinetic energy, will become equal to E square over 8 pi epsilon naught r. Okay, that is to say kinetic energy half mv square has become equal to E square over 8 pi epsilon naught into r. Dear students, here E square over 4 pi epsilon naught has a constant value, so we can write it as E square over 2 into 4 pi epsilon naught into r. Okay, so it is just a matter of discussion. Equation number 1 and equation number 2, note radial is equal to centripetal. Okay, these terms are almost synonymous. Okay, dear students, radial acceleration or centripetal acceleration are similar terms. Okay, we can also use the word radial. Okay, centripetal acceleration, radial acceleration. Okay, now using E square over 4 pi epsilon naught is equal to 1.440 million electron volt into femtometer, and mass of electron equal to 0.511 million electron volt over c square, and radius r equal to 1.2 femtometer. Dear students, this last value has been provided in the statement, while these two values have been taken from the table which has been included as a snapshot. Number 1, as a snapshot, only one snapshot is included in this problem, and this is that snapshot. Okay, from here what we have used this value. Okay, E square over 4 pi epsilon naught is equal to 1.440 electron volt into nanometer or million electron volt into femtometer. Okay, so we have used this value. Other value, this mass of electron is equal to 0.511 million electron volt over c square. Okay, Second value is this ME, where E, small e is written as a subscript of small m, equal to 5.49 into 10 raised to the power minus 4 atomic mass unit. This alternatively becomes equal to 0.511 million electron volt over c square. Okay, we are going to use this value 0.511 million electron volt over c square. Okay, so dear students, in that equation two values we have chosen from the table and third value is provided in the statement. Okay, so when we will use these three values in equation number 1, then remaining part will be just simplification. Okay, v square equal to this. Okay, here dear students, femtometer will be cancelled with femtometer. Million electron volt will be cancelled with million electron volt. Moreover, because c square is in the lower part of the denominator, so it will be shifted to a numerator. Okay, so v square will become equal to 2.35 into c square. Okay, what is 2.35? This is simplification of this. That is why we have divided by 1.440 by 1.2 and then we have divided it by 0.511. Okay, in other words, first we have multiplied 1.2 with 0.511 and the resultant value is divided by 1.440, then we get this value 2.35 into c square. Dear students, value of c is also given in the table. Okay, but the only difference is that in table value of c is given as 2.998, but we have used here value 3. Okay, value 3.0 or 2.998 are same. Okay, no difference. In table, value of c has been given as 2.998 into 10 raised to the power 8 meter per second. Here, because c is in square, so 3 square will become 9 and 10 raised to the power 8 square will become 10 raised to the power 16 meter square per second square. Okay, dear students, this will alternatively become as 21.15 into 10 raised to the power 16 meter square per second square. This implies that v will be equal to, now we will take under root on both sides, because we have not to find the value of v square, we have to find the value of v. So we will take under root on both sides. When we will take under root on both sides, then v square will become v, and we will take under root of this, and under root of this will become 10 raised to the power 8. Okay, moreover, under root of meter square will become simply meter, and under root of second square will become simply second. Okay, so our v will become equal to this under root into this. Okay, this becomes equal to 4.6 into 10 raised to the power 8 meter per second. Okay, this becomes equal to 4.6 into 10 raised to the power 8 meter per second into c over c. Here in the next step, dear students, we are going to find out the value of v in terms of c speed of light. That is to say, we can say relativistic speed. Okay, so we have multiplied and divided it by c, so it will not make any difference. Okay, because both will be cancelled. The only difference is that in the numerator we have used only c, while in the denominator we have used its alternate value in terms of meter per second. Okay, so here, dear students, meter per second will be cancelled with meter per second, and hence v will become equal to 1.53 c. Okay, so we are seeing that this speed, the hair speed is becoming about 50 times greater than speed of light. It means this is because this is greater than speed of light. It is 50% greater than speed of light, so this is not allowed. Okay, this speed not allowed. This comment is enough, because here value of v has become greater than c. Okay, here v is not becoming equal to c, it is becoming equal to 1.53 c, meaning that it is about 50% greater than C, so it is not allowed. Now we are going to part B. Okay. The potential energy of the electron nuclear system is the Coulomb potential energy, U equal to 1 over 4 pi epsilon naught Q1 Q2 over R. Okay. What is this, dear students? This is potential energy of the electron nuclear system. Okay, so here we are seeing that here R is not in square, R is in single form. Okay, why this is going to happen? This is not electrostatic force, this is potential energy. Here here R is not in square. Okay, here R is simply R power 1. Okay, potential energy has become equal to this 1 over 4 pi epsilon naught q1 q2 over r. Here q1 and q2 are both elementary charge, electronic charge E, so in place of q1 q2 we have used E square and remaining no change. Okay, equation number 3, the total energy is given by total energy is equal to kinetic energy plus potential energy, and in the previous step we have found the value of kinetic energy. Okay, so we will use here value of kinetic energy and this value of potential energy. Okay, when we will use this, then after simplification, total energy E will become equal to minus 1.8 pi epsilon naught E square over R. This is equation number 4. Okay, now we are going to find out the value of total energy by using equation number 4. We will put required data in this equation. That is equation number 4, and our solution will be obtained. Okay, using E square over 4 pi epsilon naught equal to 1.440 million electron volt into femtometer. Okay, and R equal to 1.2 femtometer, which is provided in the statement. Okay, when we will put these two values in equation number 4, then equation number 4 will become as. Okay, first we have rearranged equation number 4 in this form. Okay, because 2 has been split into 2 into 4, because E square over 4 pi epsilon naught, this has a constant value 1.440 million electron volt. Okay, R is this and 2 will be separately used. Okay, here femtometer will be cancelled with femtometer and only million electron volt will be left, and hence total energy will become equal to minus 0.6 million electron volt. Okay, if we here we can convert million into kilo. If we convert it into kilo electron volt, then it will become minus 600 kilo electron volt. Moreover, if we convert it in simply electron volt, then it will become minus 5 times 0 electron volt. Okay, that is to say, first we have multiplied with 100 to first we have multiplied it with 1000 to convert million into kilo. Then we have multiplied it with another 1000 to convert it in electron volt. Okay, so all these three values are our solution to the problem. Okay, either of these three values is a valid answer. Okay, either minus 0.6 million electron volt or minus 600 kilo electron volt or minus 6 with 50 electron volt. That is to say minus 600,000 electron volt. Okay, so dear students, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.